Day 2. Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologises for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each colour in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several times and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in Game 11, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, and 4 blue. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. Similarly, game 4 would have also been impossible because the elf showed you 15 blue cubes at once. If you add up the IDs of the games that would have been possible, you get 8. Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games?
Fantastic. So let's now break down each of these problems into its own individual components. So the ultimate goal we have is to actually have a sum of all of the games, of the IDs of all the games that are possible. What makes a game possible is that there are a set number of constraints, so 12 red cubes, 13 green cubes, 14 blue cubes. These are the constraints to validate if a game is correct or not. So when we iterate over each of the games, each game being a line on our input, we have to validate if every single pair, or like we'll call it like a key pair, is valid. So in our case, like 1 red, that's fine. That's not that is less than 12 reds. But if we look at game 3, for example, and we can see that game 3 is impossible down here, it turns out that there is a 20 red here. And then also in game 4, there's also a 14 blue. So we need to pass each line individually. So let's start off by doing that. So let's go through our kind of standard for each line in input, and we're going to go through each line. So if we just print this, we'll print line this as well, and we add that. This will print out each line, so pretty much the same as what we just saw a minute ago, but without the input. And I am going to actually, instead of doing it all natively in one function, I think it's worth like maybe using something a little bit different. And what that different is I would actually like to use the from trait. The from trait allows you to create a strut and associate a trait, for example, this from trait with it. And it allows you to convert, and the kind of practice of using this is a value to value conversion. So it allows you to convert a specific type to another specific type. And that type being T in here. So as long as we have a function called from, and it's a required method, function called from, and it allows us to actually convert one type to another. So I think this is a really useful trait to know in general when it comes to Rust, and it would be amazing to try this out. So that said, now let's actually take a look at how we would implement this. So I would like something like if we could have a game where we create a strut where we're maybe using this line from we want to convert this game using that from trait. So let's now create a strut called game. And we're going to do two things. We're going to have an ID in here, I32, that's fine. And we're going to also have a possible value. So is this game possible or not? So we can save this. This is all great. Of course, it still doesn't work. We'll actually, because we want to maybe print this game, I'll do that now. Actually, it's worth adding it as we're talking about it. Is we'll add a print line here as well, and we can print this game. But what we have to do if we do this in Rust is that you can't just do this. You need to write, for example, I'm really big fan of using a lot of the derive macros as well. So like derive debug, you can do default and clone and these kinds of things as well. I don't think it's actually needed for this, but we'll add them anyway. So we want to implement a trait, the from trait. So there's from. Another one to really look at as well when it comes to this is also the try from. This is it pretty much the equivalent, but it allows you to return a result. So if there's content that you know we can't parse or there's not a default state, I would use try from. But today we're going to use from, so it's going to be like, hey, we can parse anything. We're going to provide it with a type. In our case, it's going to be a string slice, and we need to use it for game. So if you have like VS Code, NeoVim, etc. set up, you will actually be able to, it will let you know which functions that need to be implemented or types and things like this. In our case, we need the from, and it returns a self. So you could, for example, return a game, not a new. Actually, we'll be lazy, and if we do add a default here as well, and we're missing that, we can actually do a quick default, and this will just work. So right now it will return something. Oh, I added that question mark. That's just me getting used to that. This will return the games, and the games will just be the blank state. Now, what we need for games is we'll have a mutatable game called, so we just do game. The ID we're going to set to default, so we'll just set it to 0. But we want to set the possible to true. So we want the state to be true by default. This is actually quite a useful feature. This means that, and I'll add game here. This means that actually by default games are always possible, and then it's for us to validate whether or not a game is not possible. So how do we know if a game's possible or not? We need to iterate over each of these values, and this value, let's take some of that input from, let's take an example of game 1. We need to take this input and convert it in such a way that we know for a fact that we need to validate all these specific things. So let's take the first game. So maybe we start off by splitting it into the game string or something like this. Maybe let's just call it game str for now, and then this will be the cubes, for example. And we're going to use the Rust string value dot split once. So this will split it on one particular thing. You could use split or some of these other ones. I think split once is exactly what we need. We're going to do it on a string of colon space. So we want to split here to get that first game and then the rest of it. We also do need to unwrap. Of course, wouldn't do this in production, but we know what the input's going to be, and we don't really care that much. So we're going to use unwrap. Fantastic. Last thing that we want to do is actually set the game ID to game string dot. We'll just use a replace. I'm being lazy today. Replace game with nothing. That returns a string. And then we can use the parse function and then an unwrap as well. This should give us an ID that's valid. And then hopefully at the bottom, yep, we can see here now, ID equals 1, 2, 3, 4, 5. Fantastic. So that's done. Now we can move on to the actual validation of the cubes themselves. So this should be relatively straightforward. We should actually be able to grab the cubes, and we're going to actually use a couple of splitting methods on this. So we're going to split this by, it could be any number of splits. So what we're going to do is we'll actually take this and move it here. And we'll let's remove this so it's a little bit easier for us to understand. And we're going to actually split by this semicolon first. I don't think it should matter too much, but I think it's, for me, it makes a little bit more sense, because if we have to in the next challenge, in the next part, do anything with subsets that we saw earlier, like if we look at this, like there's like it talks about the first like subset of cubes, it would be nice to make sure that we have this. So we'll just split by that. We're going to use a for each with this iterator and provide it with a closure or a function. And this will be we'll call it the subset, which is also a string. We can semicolon this. That's all good. So for each of these subsets, we want to then split this apart again into like the subsets. So we'll call this subset dot split again, but we're going to split on, oh, not a char. We're going to split on the semicolon here. And then we're also going to do another for each in here as well with a closure. We'll call this a cube. Oh, cube. And we want to run this as well like that. So let's make this a little bit bigger. And we're doing this, and we'll just print line the cube just as like a simple activity. Do that. It's going to make it a bit more pretty print. Right, fantastic. So we've got each of the cubes split out. Fantastic. Next part that we want to do is actually parsing of the cube. So we can leave that print line in here, but it's not really needed anymore. We want to do two things. We actually want to split out the number. So in this case, it might be the count string or something like that, or the string slice. And we want to split it out by the color as well. So we want to take the cube dot split. Should we do split once? Yeah, we can use split once with split once as well. And we're going to split it by just space. So we could actually use a char as well if we're being nice around this. We'll also use unwrap as well, but something to keep in note that you probably don't want to do this in production or like production code or anything like that. But to solve this challenge, it's perfect. We're going to use a count I32 just to store, like to parse that actual that count string into an actual integer that we can actually use. So we'll just use parse and unwrap again. So there's a lot of unwraps in this code today. So now if we do a quick print, and we'll actually take this and print, we'll just undo it there and call it count. Something like that. That'd be fine. Let's have a little look. And now we see all the numbers. Perfect. So that's it's cast it to an I32. Fantastic. Or it's passed it into an I32, I should say. So now what we can do is we can do my plan is maybe to use a match statement. I quite like match statements. We could do it a couple of other ways. You could do maybe a lookup or something like that. I think we're just going to use a match statement, I think, for this. So let's create a result of this. So we want to create a check to see whether or not the color that is passed in. So in our case, let's pick red, for example. Red, and we want to make sure that we actually validate like this specific count that we have up here with like our boundaries. So let's do count is greater than 12. And then we can do something like green. Oh, green is also the count is greater than 13. And blue is the same as well, but it's 14 here as well. And of course, Rust's match statements are really interesting. It needs you to make sure that you like complete it all. I always set this either to a panic or a to-do. Maybe a to-do actually makes more sense, as we can see down here. We could just set this to to-do, maybe set to more colors, question mark, and leave it there. Perfect. So we have this result. So let's quickly now set the game. So if we wanted to set the game.status, or not status, possible to the result, we need to be very careful of this, because what if the last statement sets it to true or false as well? So we need to validate this, make sure that we don't reset it, and we only set it to, I think we set it to true up above. Yep, true here. So if we can set this result to, or check this result, if the result is true, we'll set it's not possible. So possible or not possible as well. And if we save this now, this should be, oh, have I made a mistake? Let's have a quick look at this. Count I32. So all these should be possible. Why is this not working? It might be something to do with the parsing. That looks all right. Um, the match statement. You could make this a little bit easier, a little bit cleaner, but I'm gonna just keep it like that. Um, ah, okay. Is it to do with the game? I don't think so. Let's have a re-look at this. Semicolon, we're parsing all that. Let's just make sure that we're getting the right results in here. Print line of the cube here. Yeah, well, oh, and a semicolon. Never forget the semicolon. Let's have a little look. Right, so counts is the count result. It's a boolean. Okay, it is returning a boolean. Just make sure that's correct. If the result is true, then we want to set the game to not to result. We just want to set it to false. There we go. So we don't want to set it to the result. We want to check the result and only set it to false when we know it's not true. Okay, cool. So if we now rerun this and remove that, we will now get the result of, okay, 1 is correct, 2 is correct, 3 is not possible, so this is possible because false, the same for 4, and the same for 5 as well. And of course, looking at the end or the last bit of how this specific day, it actually turns out that we need the sum of all of the IDs of those games. So all of the games that are possible, we need to like add them all together. So let's quickly do a total. Just set it to 0, and we'll print that as well. Total. And then here we'll just do total as well. Easy. And then here we pause the game. Fantastic. And then we do it if game.possible. If it is possible, then what we'll do is just add that number to this. So we just do add to the total, and it's the adding of all of the IDs, all of the game IDs right here, ID. We just add those together, add that there, run that. Let's just do quickly that. We get 8, which is correct. So let's now use the inputs, the full input, and hopefully get a value, 2156. We'll copy this, put it into our puzzle, and let's see what it works. And it works. Fantastic. So that's part 1 done. Let's move on to part 2.
Part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each colour that could have been in the bag to make the game possible? The power of a set of cubes is equal to the numbers of red, green and blue cubes multiplied together. The power of the minimum set of cubes in Game 1 is 48. In Games 2 to 5, it was 12, 1560, 630 and 36 respectively. Adding up these 5 powers produces the sum 2286. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets?
Fantastic. So let's take a look at the requirements for part 2. We can see right at the bottom what the requirement is as the end byproduct, where we need the sum of all of the power of all the sets. Okay, fantastic. How do we get the sets? And how do we get this power as well? And it turns out the power is a set of like the highest value cubes that we can get, or the fewest number of cubes for each color. So in each of the sets, we need to double check, like, okay, what is the highest color? So in example, for something like number game 1, we need to make sure that we have 4 reds, because there are reds repeated a couple of times, but there's a 4, there's a 2, and then there's a nothing. So we need to pick this 4. The 2 green is the same as well. There's only 2 green here, but there's also another 2 greens there. And then, yeah, so on and so forth as well. And to obtain this power is pretty much all 3 of these numbers. So the max red, max green, max blue multiplied together to generate the power. Okay, so that's very straightforward. It shouldn't be too hard to add to our code. Let's start by adding the input. So I've just got the test input here. It still works with the previous code. We go back to day 2 now. We can just quickly have a look at our code. all those requirements. So we need to find the max value or the max number for each of the colors. So maybe what we'll do now is add in all of the different numbers, all the different colors. So we'll start with red, then maybe we'll put blue in, and then green. That should make it really easy for us to identify this. And this will be our like max value of this as well. And thankfully we have, okay, I know what this is. This is because it needs default values. We'll remove the ID because we just need to just have default. So it was good that we had this before this default macro. This will just set all of the I32s to 0, and that's kind of what we want. So let's set that to 0. So what we need to do now is every time we look at a red, we need to look at the current game and see whether or not the current number is higher. And if it is higher, then we need to set it accordingly. So the really nice thing about this is it shouldn't be too difficult. We can actually just extend what we have in these like branches. So for example, in our match statement, so let's take an example where we could just do a really simple like if game.red greater than the count. Yeah, the count is up here. So this is our count. And we want to set the game.red to count if it's higher. But we still want to do this. I don't actually know if we need this for the second part now, this count. I don't see any requirements around this, but we'll leave it in here. I think it shouldn't be too bad. We'll rerun that. Of course, we don't see anything. Let's add a print line of game. Let's do game here, rerun. So now we're seeing all the numbers. So red 4. So let's take it over to our input. So red is 4. 2 is 1. Then it's 20, then it's 14, and then it's 6. So perfect. Okay, so this works with our code. So we need to just do this for the other remaining ones. Can I just yank this and paste? It probably will work. So we can do this, and then we can just add a few enters, paste that in, and just replace this green and this with green as well. Save that. Copy that, and then move it down into this branch. So I think there's a nicer way you could do this. I'm just doing this for simplicity reasons. I don't think this needs to be any more complicated than that. It formats it, runs it. Right, we've got all the numbers. Fantastic. And then we need to get this. What was the word that was used? I think the word is we need to generate a power value. So this would be pretty much power value is the multiplication of all of those numbers. So we need to do game.red times by game.blue times by game.green, right? And then what we'll do, just so we can see what that value is, we'll just add it to our print line. So once this runs, we'll get a bracket at the end. And this had to be a 42 for game 1, and then for each of the games, it's 12, 1,560, 630, and 36. So that is perfect. Okay, and that's it. And so the last thing we need to do is the sum of all these. So we'll reuse this. We'll reuse this. We'll comment out this for part 1, and I'll even add a little part 1. We'll actually do here is the total. Total is equal to, we just need to add the power to the total. We'll run that. We'll run it, and we need to get 2,286, which we do. Fantastic. So now let's run that on the full input. So part 2 full, we're going to get 66,909. So let's take this now, put it, submit it, and we're done. Easy, really straightforward, really simple, that part compared to the first bit. So thank you for joining us on day 2 and finishing up the second 2 gold stars. Join us next day for the next part. Thank you so much, and take care.